Hi there. In this video we're looking at surface area, and specifically we're going to look at how we find the surface area of a cone. So strategy is exactly the same as in the previous video. We need to label up our sides and find the area of each surface. So we've got this one face on the bottom, this circular face. Let's call that 1. Oh dear. Let's call that 1. And then we've got its second surface. We've got the curved surface. Let's call that 2. So if you can't really sort of visualise what the curved surface looks like, I've got my handy cone shape here. Now ignore the fact that it doesn't go to a point. It should go to a point if it's a full cone. We've obviously got the circular face on the bottom, and then we've got the full continuous curved surface around the outside. So if we follow the strategy from the previous video, and then we say, well, 1, well, the area of that, it's a circle, so the area is equal to pi times by the radius squared. The radius is 4, so you get pi times by 4 squared, which is 16 pi. It's fairly straightforward so far, but then we get to shape 2, and we come a little bit unstuck because, well, we don't know how to find the area of that curved surface. That's a bit of a weird thing to do. And so what we'll do is, just in the next part of the video, we'll explain how we come up with the formula for this, where it comes from, and then we'll revisit this question with how to use that formula. It's quite a straightforward formula to use once you've got it, but I do just want to explain where it comes from. Okay, so let's have a look at how we find the area of the curved surface. So I just popped this question up in a box up here, so we've got it in the back of our minds, but really what we'd like to do is come up with a formula to find the area of this curved surface. So what we'll do is we are going to try and do this generally first of all, and then we can go back to apply it. And there's no point just doing it for this one circle or this one cone, because we'll lose track of where the numbers went, and then it might be hard to go back and then do it to a different cone. If we do it generally, we can use it on any cone. So what I've got for us is I've made us a lovely paper cone. Looks a bit like a hat. And it's a lovely paper cone. And you'll see if we unravel the cone, it gives us a shape that we should all be familiar with. It's Pac-Man. No, it's a sector, circular sector, and we should know how to find the area of a circular sector. It's just a fraction of a circle. So you might be thinking, well, normally to find the area of a sector we need the angle, but there's something quite clever we can do to work our way around that. But let's just have a bit of a look about some of the lengths on this circular sector first. So if we look at our diagram, the length of the slant, when we unravel it, let's just label that onto our cone. So the length there, that's backwards, no, it doesn't matter. And the length of the cone, if we unravel that, then that becomes the radius of my circular sector. So if we draw the sector out, close enough, and this here, that length is L. Okay, so to find the area of a circular sector, we need to know the radius of the circle, which we've got. We also need to find what fraction of the full circle we have. Now, ordinarily, we might want to find the angle and then do that over 360, and that will give us the fraction of the circle we've got. But we can do something slightly more clever here, slightly sort of feels a bit more magical. What we can do is we can work out the fraction of a circle by using the arc length. Okay, now let's have a bit of a look. So the arc length on our circular sector is this black line that goes around the edge of the circle. Now if we refold our pyramid back up, you'll notice that that arc length is just the circumference of the base of the pyramid, of the cone, sorry. So that arc length is just the circumference of the base of the cone. Now, the base of the cone has a radius r. The circumference is equal to pi times by d, or 2 times pi times by r, because the radius is half the diameter. So 2r is the diameter times by pi is the circumference. So this length here is 2 pi r. Now, what does this allow us to do? Well, if we had the whole circle, so if we had, let's do this in a different colour. If we had the whole circle, then the circumference of the whole circle, let's do it in a, okay, so let's pretend that we've got the whole circle. And so if we had the whole circle, the circumference of the whole circle would be 2 times by pi times by the length. And that allows us to work out what fraction of the circle we've got. If the whole circumference is 2 pi L, we only have 2 pi rths of that circle. So we get 2 pi r over 2 pi L times by the area of the full circle is going to give us the area of this sector. Now, the area of the full circle is pi r squared, which is going to be pi times by L squared. And then we can cancel this down. So this pi is going to cancel with this pi, this 2 is going to cancel with this 2, this L is going to cancel with one of these 2 L's up here, and what we are left with is pi times by r times by L. And that is the area of the curved surface of a cone. So in a second we'll have a look at how we apply that to this. Okay, so let's pick up where we left off here. So we just found the area of the circular base, and now we need to find the area of this curved surface, number 2. And now we've just worked out that the area is pi times by the radius times by the length, or the slant length. So we call this slant length L. Let's just label that on here so we don't forget. The height, which we use to work out the volume, we call H. So some questions will ask you for the volume and the surface area. You just have to be really careful that you're using L when you're working out the surface area. But area is pi times by the radius times by the length. Now the radius is 4, the length is 7, we times that by pi, 7 4s are 28, so we get 28 pi centimetres squared. So then our last step is to work out the final surface area, which is 16 pi plus 28 pi. And now, just like with algebra, if this was 16x plus 28x, we just add the coefficients. We do exactly the same thing here. So 16 plus 28 is 30 plus 14, which is 44 pi centimetres squared. Again, as with all these questions, if it asks you for your answer to 1 or 2 decimal places, you type it into your calculator and get a decimal. But for this video, I think we'll leave that in exact form. Good job.